hydrogen bonding with Mitchell, Ira, and Todd.
The definition of a hydrogen bond is the attractive force between one molecule with a strongly positive atom bonded with two hydrogen atoms to another molecule of the same composition. A hydrogen bond is classified as a covalent bond, however, is slightly weaker. A hydrogen bond is also a type of dipole force.
Hydrogen bonding was first examined in the early 20th century. In 1920, Latimer and Rodebush, working on the structure and properties of water, proposed this. A free pair of electrons on one water molecule might be able to exert sufficient force on a hydrogen held by a pair of electrons on another water molecule to bind with two molecules together. Such an explanation amounts to saying that the hydrogen nucleus held between two octets constitutes a weak bond. A hydrogen bond is responsible for surface tension and occurs in three elements: oxygen, nitrogen, and fluorine. Polar molecules are molecules with a partial negative charge and a partial positive charge. An example would be a water molecule. Since a hydrogen has partial negative charge, therefore it attaches to an electronegative atom such as the elements mentioned before.
When the hydrogen molecule is attracted to a negative molecule, this attractive force is called an electrostatic interaction. But one thing to know is that a hydrogen atom cannot attract to another hydrogen atom. Also, that a hydrogen bond is not really a bond. It's more of an attraction more than anything.
The shape of the water molecule is a bent shape. Water is also known as having Mickey Mouse shaped molecules. This shape is created by two hydrogen atoms connected to one larger oxygen atom. The head, which is the largest part, would be the oxygen atom, while the other two hydrogen atoms would be the ears.
The Lewis dot structure of a water molecule has a chemical formula of H2O. Therefore, its Lewis structure would be the image displayed on the screen. The dashes are the bonding electrons, while the two pairs of electrons on oxygen are what is called non-bonding electrons.
Hydrogen bonding is an intermolecular force because the hydrogen atom being pulled to the electronegative atom is an intermolecular force, while in water molecules there is an intramolecular force because the two hydrogen atoms are attracting to the oxygen atom of the same molecule.
In the periodic table, you would notice that the highest value of electronegative elements are in the same place. Hydrogen bonding fits into the periodic law because the three most electronegative elements on the periodic table, which are oxygen, nitrogen, and fluorine, are located in the nonmetals family. They are the only three elements that have electronegativity high enough to trigger hydrogen bonding.
Attraction between molecules in which hydrogen is bonded to highly electronegative atoms such as oxygen, nitrogen, and fluorine. Water is an example of a substance where hydrogen bonding occurs. The highly electronegative oxygen atom draws electron density from the hydrogen atoms, giving oxygen a partial negative and hydrogen a partial positive charge. The attraction of opposite charges toward one another causes the hydrogen bond. In liquid water, the attractive force is transient. Water's relatively high boiling point is caused by this force. As water cools and molecular kinetic energy decreases, hydrogen-bonded clusters form. On continued cooling, these clusters of molecules form ice. Due to hydrogen bonding, depicted here by dotted lines, the structure of ice is less dense than that of liquid water.